This is a Carboline production.
Here we go again, another episode intro where I travel back in time. Although now it's only a short while. At the start of episode 14 this past summer, I said something was happening right below your feet. It turns out that was just one thing out of many. Today we're talking about another, static electric discharges. And these are not your playground variety static electric shocks that you feel if you zip down a plastic slide. These shocks, they could potentially wipe out whole sections of the internet, including the part that holds your favorite podcast. One way to minimize that risk is to apply specialty floor coatings known as conductive or dissipative. And because that distinction is the source of a whole lot of confusion in the industry, to say nothing of the confusion it's caused me, we turn to the wisdom of an expert. So Richie Cropp of Dudick joins us on the Red Bucket, and I think this is your first time on the show, right, Richie?
It is.
And your role with Dudick, you cover a lot of ground as I understand it.
I'm the subject matter expert for the Dudick product line, which encompasses flooring, containment, and some specialty coatings as well. But I cover pretty much the Northeast, scattered around supporting other of our colleagues at the job sites and things like that, all over the U.S. and internationally.
How long have you been in flooring?
19 years.
Well, one of the things that Richie isn't, if he's a jack of all trades on the job site or in his role with Dudick, what he's not is not an electrical engineer, and neither am I. And we might get to a point later in this discussion where you'll wish one of us was. But I wanted to start it off that way, Richie, because I brought this topic up to you a few months ago. And when I did, you said you would need a glass of bourbon before we talked about it. How come that was your reaction to my invitation?
Because historically, the two characteristics of flooring, conductive and ESD, or as it's known, static dissipative, gets confused. It gets confusing as, what are the differences and the different applications where it should be used. I mean, it's just been extremely misrepresented on some jobs. So that's why I said it gets confusing. That's why I need a glass of bourbon.
I'll admit that I spent a couple afternoons, different afternoons, reading about this, and I think I ended the first handful of those sessions feeling the same way that you did, because it wasn't really completely clear to me what we meant by that. Things have changed, and I feel like I do understand it better now. I've sat with it long enough, but I want to set the stage a little bit for where is it that we encounter this topic anyway? Because when it comes up in conversations, at least in the more recent handful of years, they're talking about data centers. Sometimes they're talking about electronics manufacturing. There are other places, we'll get to that too, where this is a concern, but those are the ones that come up because these are hot items. We're talking about uncontrolled electrostatic discharges, which can hurt the equipment. Take it from there, Richie. Maybe you can put a little more color into what I've just said. What is this phenomenon that these types of flooring are meant to try to mitigate?
Let's take data centers, for example. You touched on that. What you have nowadays is the internet is housed in these very large warehouses, and they are secure caging. And what happens is you generate a lot of heat because of the servers that are running in these racks, especially in the wintertime. As we're approaching the wintertime, when you get up and you have two dissimilar surfaces, that being, let's talk, let's do layman's terms, your rubber sole shoes, and you're in a room, an office room, and you have carpet on the floor. Well, those two dissimilar surfaces, when you rub them together, creates a tribocharge. And when you touch that doorknob, lo and behold, you get a little bit of a spark. So think of that concept when you're in a data center. You have a flooring system Or let's just say if it was a neat concrete floor, by definition, concrete is insulative. So it's holding, the salts and things that are part of that hydration, that formulation will create electricity with a rubber sole shoe going across it if you were to walk over top of it. So what we do as formulator manufacturers in the flooring industry, we will incorporate a filler into the resin, and when it's applied, it gives it static dissipative properties. What that does is that mitigates the chance of any spark or tribo charge when workers are in there, working on the equipment, switching out like a hard drive or something like that. They all obviously use, I've heard facilities wearing boots like PPE that have that as a second line of defense to protect the equipment, as well as those wristbands where they put a little clip onto the steel cages to kind of help mitigate any additional tribocharge or static electricity, that would potentially damage the equipment. So hopefully that kind of gives you a comparison between something that happens every day that us, in an office space would experience in the wintertime specifically.
Same kind of thing that maybe I experienced if my older brother rubbed a balloon across my head
Yep.
or dragged me across the carpet.
Right.
And you brought up a couple of the, I would say, adjacent ways that that risk is mitigated. Those could be episodes all unto themselves, where this isn't just floor coatings. That's not the only way to do it. You referenced the footwear that people are wearing. I
Hmm.
was reading the material of certain furnishings in the space. I don't know if that's desk chairs or cabinets or tables or, whatever have you. There's materials in use in the makeup of those furnishings that also control these rogue electrical charges. But we're here to talk about flooring, and I I came across at least two. There might be more, but two standards that maybe we should name check. The one that kept coming up as I was reading was the ANSI ESD 2020.
Yeah, that is the standard that we reference within our product data sheet for conductive and or ESD or static dissipative.
And do I understand it correctly that that standard it tells you how to develop a program or a strategy for controlling ESD, but also then can define the actual composition of flooring materials that are used in a space? It does both of those things?
It breaks it down based on ohms of resistivity. That's the range that it references to determine whether it's one or the other. And a conductive floor reads in ohms and resistivity anything a million or less, versus ESD or static dissipative is between a million and a billion ohms. Based on the reading, how the floor reads determines what category. If it's conductive, it's one, and if it's ESD, then it's the other.
And we are into that territory where an electrical scientist might have been helpful because I was thinking about, I've read those same numbers. So the up to a million ohms for conductive and dissipative ranging from a million ohms to a billion. I don't know after how many pieces online did I have to read before I got this. I was thinking that electrostatic dissipative and conductive were opposite ends or opposite extremes on a spectrum. But no, those are both means of moving electricity safely away from someplace you don't want it. I don't want to draw a reference that starts to confuse people here, but think about conductivity of certain regular materials like copper wire, very conductive. A hunk of rubber, not really. And so when the figure is the lower figure up to a million ohms, this is more highly conductive, right? Less resistant. So the flow of electricity is easier and freer.
And both of them effectively reduce the amount of electricity or static electricity in within that environment. I believe that would be a fair assessment.
The question that nags at me, whether the electricity is flowing much more freely or much less freely, is it's gotta go somewhere. Where's it going?
To true ground, essentially. It's to true ground.
I saw a graphic online that made it look like structural steel beams become part of that conductor, if you will, sending
It
it down to ground. Is that true?
it is. When it's installed, I think typically it's every 1,000 square feet. Like a connection. Typically, they use the steel beams within the shell of the building to help make that connection.
Does making that connection mean that the installation of either the flooring material or the installation of anything on top of or around those steel beams have to change compared to normal?
No, it's just that connection or that contact has to be within the layer of the flooring system that has the fillers, be it, ESD or conductive,
Mhm.
for that connection to work. And obviously that can be tested after the entire floor is installed. That's part of the QC parameters that us flooring manufacturers or the installers generally, hire a third party or do themselves.
You've referenced a couple times now what is actually inside the flooring system to make it more or less conductive. It's not like you're grinding up copper or laying copper wires down, into the epoxy before it cures. So I'm wondering, what is it actually inside? What's the stuff in there that makes it do this?
That's proprietary. But typically for conductive, it's graphite filled fillers that are used.
Hmm.
But on the ESD side, I don't know the material makeup. I honestly don't know. I've asked the question, but given the same answer, it's a proprietary filler.
There's a someone in a lab coat keeps that very safely tucked away in a file cabinet in the sub basement of a building. No one knows where it is.
Yeah, and it's locked.
So suffice it to say, there are materials that conduct electricity well, and there are materials that conduct it less well, and those are in the film of the floor topping. You can put it that way. You've been on the ground on these projects, so what is it like for whoever it is that's responsible for deciding one or the other? How hard is that?
It's not that hard, in theory, because let's take conductive. We've done applications for the NASA program and their ICBM rocket areas where they build them, and when they test them, that space is a conductive area. If it was not conductive, that would be a one-time event. The flammability and all the chemicals that are used in that space. So we always say, if you don't really seek out your material supplier and really have these conversations and qualify things, you could have a catastrophic failure. A one-time event essentially on your hands, and nobody wants that. So, for example, in the pharmaceutical industry, sometimes these owners will have like what we call chemical storage rooms. And what they do is they have totes of potentially flammable liquids housed in these spaces. And the requirement there would be to have a conductive floor to help dissipate that static electricity in the event of a spark or something like that. Or, you've got a tow motor that's banging on the floor and it creates an arc and you've got an open container of a flammable liquid. That potentially could be a hazard. When you're incorporating conductivity into linings or for tanks and things like that, when you're trying to do spark testing on certain chemicals that would attack, silica, you need to incorporate a graphite filled resin, which gives it conductivity to protect that lining so it doesn't deteriorate quickly in the event of a spill. So that's more on the industrial side.
I'm glad you brought those up because the generalization that I saw in my reading showed that in areas where you have something that's highly flammable or something that's explosive, generally this is where you'll see conductive because they want that discharge to be done away with completely.
Right.
conduct it away as fast as you can, get it out of there, compared to dissipative. And this is where, data centers, server rooms, those kinds of places. It's not that we're tolerating electric shocks there. It's that we're moving them away more slowly. It's not as fast, not as instant, and not as complete as a space that has conductivity, let's say.
Right, right. And the envelope is not as critical as flammable. It's not flammables or, things like that that could, again, explosions could happen.
Is it ever the case where on a construction project where you might have different rooms or different spaces within one building envelope where you would have both?
Yeah, I mean, if you get a complex, you know, reactors for pharmaceutical, and then that's conductive, and then the chemical storage room, and then maybe you have like equipment that would need to be protected, high end equipment in a laboratory space where they're doing sample testing or something like that. You would need ESD.
Are there ever situations where you're in an environment where it could go either way? You could get away with ESD, or you might want to do conductive. Does something ever straddle that line, or is it pretty cut and dry based on circumstances which one is the right way to protect the space?
In my experience, it's always been a clear, definition between the two. I could see where potentially it could be either or. I think that would be a situation where it doesn't involve flammable liquids, though. But it could be just a chemical exposure from a chemical attack standpoint, not the flammability concern.
I don't think anybody would encounter that line, that one or the other, and then just decide to do the one that's less safe if it was a safety critical space, right? I mean, if it's you sort of err on the side of caution.
Right. Yeah. I agree with that.
Whether a floor is conductive or whether a floor is electrostatic dissipative, how do those compare to what you would consider a normal general purpose floor topping?
As far as durability, the makeup, the resin formulation is very similar in most cases. So they're built from robust materials, be it, epoxy, different epoxy formulations that can withstand heavy traffic and wear. And they're both very versatile. It's more a difference in aesthetic because there are limitations with conductive floors as far as the overall makeup, the matrix of the floors can be similar to just a standard, you know, epoxy floor topping. It's just different, filler packages to give it these unique characteristics.
What sorts of differences, like as I look at a floor, would I be seeing from one to the next?
Well, conductive, the fillers, to my understanding, are like a darker color. It's so most of those floors are pigmented, or actually all of those floors are pigmented. So we generally only have like a dark gray or a tile red, and it's something in the darker tones. Medium gray is going to lean towards more of a darker medium gray. So that's where I say the limitations are there. Um, but for ESD, we have offerings of a solid color, and those again, there are some limitations in the pigmented offerings, but we have a translucent static dissipative top coat as well, which can be applied over flake decorative systems like a decorative flake or decorative quartz
Hmm.
systems. But they also have out there decorative fillers that have like a graphite quartz in it. So you get those properties within the broadcast itself. So you have offerings of floors that have ESD throughout or conductive throughout or just on the top layer.
I can only imagine how someone who isn't in this world every day, like me, is going to become pretty easily confused and want some help. I would be desperate to know, what do I have to do this right? Because I, like you said in your NASA example, I don't want a one-time event. What are the ways that the manufacturer, the Richie Crops of the world, can be of assistance to the folks making these material decisions?
Well, obviously, for someone that has some understanding of the differences, and then ask those poignant questions, always say, "Are you sure it's conductive?" If an architect or an engineer comes to me, is like, my customers reached out to me and needs a recommendation for a conductive floor, and I always say, "Are you sure?" And then the next question is, "What are the ohms and resistivity requirement for that space?" And most times they don't have that information, so we have to have a dialogue to qualify
Mm.
that. I mean, it's because it is a critical ordeal with when dealing with those types of applications. But once we have some dialogue, we can help point them in the right direction. Yeah, this sounds like this is probably the way you need to go.
Have you ever been on a project where the owner or the contractor or whoever is involved, went rather far down the planning process, assuming or planning for a floor needing to be one way, dissipative, let's say, and then they talk with you and they talk with you a little too late, and then you tell them, no, 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 you need the other kind. And then they're like, oh, wow, we just dodged a bullet there. Has that ever happened?
In my experience, fortunately, it hasn't, but I know some of my colleagues have run into situations like that where, yeah, we've been in discussions with facilities and or design team and made the recommendation to change it from one to the other. Historically, Dudick has been in situations like that.
How do these two types compare, dissipative versus conductive, in terms of installed cost?
Install costs, they're generally right about the same. Maybe the ESD being maybe 50 cents a square foot less, just because of the fillers that are used. But yeah, I mean, install costs is generally about the same. And again, it's a range because of, again, the overall matrix. You can offer a thin film ESD or conductive floor, or you can do a troweled mortar with those same properties. So again, the cost, it'd be hard to give you an estimated square foot cost for all types.
I guess just the thing to close on before we move on to the fun part of all of this. The people on the buyer side, let's say, on the
Hmm.
builder's side, need to lean on the people who know about this stuff. I think anybody anywhere in construction would agree just generally with that statement. But when it comes to this topic specifically, certainly when you're dealing with a space, you know, petrochemicals or munitions or, you know, any place where there's rocket fuel like your NASA project, you don't want to guess. You don't want to get it wrong. So the red bucket always has 4 questions. Richie, are you ready to answer 4 very, very important questions?
Fire away.
Okay. Question number 1. Suppose that you have just had a real doozy of a conversation about conductive or ESD flooring, and you can't think of a better way to wind down after that conversation than to have a glass of bourbon. What bottle are you reaching for?
Woodford.
Okay, Woodford Reserve. That's somewhere near Lexington, Kentucky, right?
Yes.
I don't know that I've had any. I might have had like one half of one shot once, but I hear everyone I've talked to who's had it loves it.
Yeah.
Okay. Number 2, Richie, happy Thanksgiving. This episode's probably going to publish right around Thanksgiving time. So I got the idea for this next question after speaking with Dan Barabalt and Paula Jamis. Those of you listening, go back to episodes 15 or 16. But for Thanksgiving, Richie, what's the pie? What's your favorite pie?
Pecan pie.
That was one of Dan's favorites too.
Hmm.
Dan couldn't decide. He said it was either pecan or pumpkin, and then just decided to bring both. It's still Thanksgiving, and I would ask myself this question and answer it very easily, but I wonder, would you rather host Thanksgiving dinner or would you rather go somewhere to someone else's house and have it?
Host. My wife and I are big hosting people. We like to entertain.
I see. You've hosted a wonderful Thanksgiving dinner. Your family was there, your friends were there, everybody had a nice time, and now it's Black Friday. You strike me as the sort of person who values your own sanity. So I assume that you are not out shopping.
That is correct.
What are you doing instead?
Um, if it's warm, maybe an afternoon golf round, or resting from hosting the day before.
It's that kind of a party, huh?
Yeah, yeah, yeah.
Okay. Well, thank you, Richie. This was really great. It was enlightening. I'm a little less confused than I was at the beginning, and I'm hoping that anyone else who hears this leaves this knowing at least a little bit more about a topic so severe that it leads people to start drinking.
Yeah, right. Yeah.